everyone. Good morning, good afternoon, good evening, wherever you are. Welcome to this episode of Capture 3D's webinar series. We're excited to have you here today. We're going to wait a few seconds to make sure everyone is settled and ready to go. We'll just give everyone a couple more seconds to log in before we get started. Again, thank you so much for joining us today and for waiting. My name is Emily Starneri, and I'm the content creator here at Capture 3D. We're glad you could join us for the 8th episode of our webinar series, where we're going to dive into how 3D metrology is a critical success factor for your digital transformation strategy. This month, we picked digital transformation as our topic, but if you are interested in other topics and applications, here's a list of some of the previous webinar topics that we've covered, as well as a glance at the topics that we have in the pipeline. So webinars are just one of the many free digital resources that we have to offer the Capture 3D community. Our website also features insightful blogs and helpful tutorials that can help you and your workforce enhance your digital engineering capabilities. Just some quick housekeeping. If you have any questions for us during the presentation, please leave them in the chat section and we will address them during our Q&A at the end. And please make sure to direct your questions to everyone if you have that option on your WebEx, or select all attendees so everyone can see your questions. Here is our agenda for today. We're taking you through a digital transformation journey from concept to strategy and process to implementation to explain why 3D metrology is a critical success factor for executing this initiative. First, we'll discuss the concept behind digital transformation, addressing what's real versus what's hype. Then we'll dive into explaining how to leverage digital transformation as a strategy to help you remain competitive. After, our technology specialist, Griffin, will show you the simple process behind digitizing your parts, as well as the critical things that you can do with that data. Finally, we'll cover how to implement this data to make your entire organization more agile. Let's get started. First, a quick explanation of who we are and what we do. Capture 3D was founded more than 25 years ago as the exclusive U.S. partner for GOM Metrology Solutions. GOM is based out of Braunschweig, Germany, and in recent years was acquired by Zeiss. We've installed nearly 3,000 systems here in the United States, while GOM has over 30,000 sold worldwide. Our team is nearly 100 employees strong, and 65% have a technical background. We have 5 offices around the country to support our customers. California is headquarters. Michigan houses our automation and support teams, and we have offices in Connecticut, North Carolina, and Washington. Just last year, we announced that Capture 3D also joined the Zeiss Group, and we are very excited to continue to work even closer with GOM and Zeiss moving forward. For those that joined a bit later, again, my name is Emily, and I'm Capture 3D's technical content creator. I've been with the company for over 2 years, and I've been deep diving into digital transformation and digital twin strategies happening in traditional and emerging industries. I also uncover stories of successful real-world digital engineering applications. With me today, I have Griffin Gout, who is a technology specialist with Capture 3D. Griffin has been with us for over 4 years, and he is one of our experts in digital engineering solutions that enable reverse engineering, digital twin, and digital transformation strategies, helping companies from various industries adopt digital engineering technology. We're both excited to be here today to discuss this topic with you. So I'm sure many of you have heard about digital transformation many times, because digital transformation is a buzzword thrown around so often that it's tough to know what's real and what's not. But in short, digital transformation is bringing the physical world into the digital world through digitalization. We often hear about factories running on sensors communicating data to robots who do all the work for humans. But saying that digital transformation is 100% technology driven is not completely true. The reality is that it's also people-driven. It's about implementing the right tools along with technology-driven people to change work, culture, and how things are done for the better. But why change? After all, isn't the saying, if it's not broken, don't fix it, true? Well, with digital transformation, you're optimizing instead of fixing. You're finding better ways to do things, and by improving the way you do things, you're bringing value to your entire organization. Digital transformation is a continuous improvement journey powered by accurate data and the intelligence it enables. That intelligence points us to where there are errors or weaknesses in our processes that prevent us from achieving higher productivity and making better products. The strategy behind the digital transformation movement is to become proactive instead of reactive. Companies are rapidly moving in this direction to gain the agility necessary to thrive in our changing market. Undergoing a digital transformation optimizes many areas, including higher worker efficiency, cross-organizational collaboration and communication, and asset uptime. That efficiency results in a faster time to market, less scrap, and higher employee retention, which in turn increases revenue and reduces downtime. The bottom line is, leveraging digital transformation is the key to many opportunities for improvement and advancement for your entire organization. For industrial organizations, digital transformation objectives revolve around increasing operational efficiencies and improving customer experiences, which equates to revenue growth. Real-time data on the status of assets, processes, and people is a key enabler of these goals. To access these opportunities, we must embrace change, and that includes changing the way we work and the way we think about work. One of the first changes should be moving 2D processes into the 3D world, because as one of our customers once so perfectly put it, the truth is we live in 3D, so we should work in 3D. With digitized components, you can evaluate a product design to ensure it fits together properly in a completely simulated environment. You can see where changes should be made for quality, cost, and performance before ever moving into a physical process. Evaluating these processes beforehand minimizes variation, eliminates waste, and delivers a high-quality product with consistent, repeatable results. Verifying form, fit, and function by comparing actual data against the nominal design intent identifies problems earlier. These actionable findings tell you where there are problems and what adjustments you need to make so you can move more swiftly and confidently. Digitalization allows you to make faster decisions using reliable information that you won't get with a 2D drawing or traditional process. Visual data makes it easier to communicate these problems to the necessary departments throughout your organization. Having all the information in front of you in a format that's easy to understand, even for someone without any special skills or training, promotes collaboration by making it easier to communicate problems and quickly come to a decision. And that increase in responsiveness reduces downtime. So, by bringing your parts and processes into a digitized environment, you're identifying problems earlier and creating an optimized, reliable, and repeatable process that reduces the amount of waste you create from producing bad parts, making digital transformation a key driver for successful lean manufacturing. By committing to digital transformation, you have the potential to unlock all of these strategies and more. However, each of these strategies are data-driven, and for them to be successful, the data must be accurate, because accurate data is at the core of every successful strategy. Let's take model-based definition, or MBD, and product manufacturing information, or PMI, as an example. Digitally communicating your design requirements using PMI embedded directly into a 3D annotated semantic model creates utility in a downstream application and interoperability with software that increases your digital engineering abilities. With this information in one centralized place, it provides a single source of truth and a singular interpretation for anyone who works with the part throughout its life cycle. By reducing opportunities for error caused by misinterpretation, you're also fostering better communication, reducing scrap and wasteful costs. Working with PMI is key to standardizing and communicating design, performance, and quality specifications to generate consistent, repeatable results. Likewise, when you have accurate, full-field data from your part, you can do more with your data than you can when it sits on paper as rows and numbers and columns. In case you are wondering what I mean by full field data, this refers to creating a high definition digital twin of the part being digitized using 3D scanning technology. While the data shown in this image may look like a CAD model of the part, it's actually scan data coming from an Atos scanning system. As you can see, the entire surface of the part is characterized thoroughly. The resulting data can then be used for a variety of downstream applications. Having full field data capture provides insight not only into your parts and tooling, but all over the process from a micro and macro level, enabling process optimization of the entire product lifecycle and associated workflows. Digitalization enables much more beyond measurement. It enables more efficient reverse engineering, virtual reality rendering, tooling verification, equipment qualification, root cause analysis, digital twin strategies, and beyond. The future of manufacturing is data-driven, but these advancements can't happen without accurate data. Following the rules of garbage in, garbage out, the accuracy of data, how fast it is obtained, and its ability to be interpreted are key to being able to use it throughout a product's lifecycle. Atos 3D scanning enables a fast way to collect data for use in many different stages of your manufacturing process, whether you are in the designing stage or production stage. With millions of accurate data points, you gain insight into the entire product lifecycle from design to development to production for a modernized, lean manufacturing strategy. Full field data capture allows us to not only see the prismatic features present on the parts, such as holes, slots, planes, and edges, but we can also see what's going on in between those features. Using full field data, we get a very thorough understanding of what's happening with the part. For example, is there too much or not enough material? Is there enough material present for downstream machining processes to produce a good part? Are the walls too thick? What areas of the part may be interfering with other parts when assembled together? And these are just a few of the advantages of using full field data. But not all full field data is suitable to support you through your digital transformation journey. Griffin, can you show us what full field data looks like with fewer data points?
Yes, I can, Emily. Watch the features on this digitized part change from high resolution to lower resolution. You can easily see that not all full field data is the same, and you lose the accuracy as you lose the resolution. Resolution is determined by the number of points, or as we call it, a point cloud, which I'll go over in a little bit. So now that you know some of the benefits of digital transformation and accurate data, you're probably wondering how to get started with a full field digitalization. I'll show you how simple the 3D scanning process is and why it's an easy entry into digital transformation. Digitalization with Atos is broken down into 3 simple steps. First, you digitize the object by collecting 3D data from its surface during scanning. Then, you visualize the captured data as an accurate digital twin. Our customers use the data to perform faster inspection in a digitized workspace. Finally, you communicate and share the results throughout your organization with visual, comprehensive reports that are easy to read and understand. Regardless of the part size, these 3 steps are the same. We have customers in the medical field using this process on parts as small and intricate as a heart valve stent, and in the aerospace field on structures as large as a full-size C-130 aircraft. Depending on what your digital transformation goals are, there are various options that offer different advantages to help you get there, from handheld to stationary to semi and fully automated digitizing solutions. Here's an example of what happens when a company fully commits to a digital transformation. A plant operated by Volkswagen in Poland utilizes Atos technology almost exclusively, with more than 20 Atos systems throughout its measuring hall. 70% of production at this plant is made to measure, and with 1,100 equipment variants that can be configured, range of parts is vast. Ease of use is one of the main deciding factors that led the plant to implement optical full-field metrology at such grand scale. Volkswagen knew these systems are easy to use, and the full-field 3D data is easy to understand. The 56 employees of the measuring room were hired locally and trained in parallel with construction of the plant, which prevented training from becoming a bottleneck during production. In addition to the inspection process being 30 to 230 minutes faster with the Atos scan box, the FullField Data allows the function, visual appearance, and design to be checked based on dimensional accuracy to ensure the exact quality requirements of Volkswagen and its customers are met. This plant proves how optical metrology represents the path to digital transformation driven by full-field digitalization. To further illustrate how full-field digitalization is the key driver of digital transformation, I really like this visual that Emily showed earlier. And I also want to go back to something that you said. Atos 3D scanning technology is used throughout the manufacturing process, from product development, quality assurance, and production to digitizing the entire process. So, I want to show you how easy this is in real life, using a simple part to walk you through these three processes and show how digitalization enhances every part of the product life cycle. First, I'll show you how quickly you can digitize a physical part with Atos and then use the resulting data to perform a few basic inspections using the GOM Inspect software. Following that, I'll show benefit of FullField Data for tooling and how digital assembly allows manufacturers to assemble parts and components, validating their process without having to physically assemble them. I will then end with a discussion on how automation can help improve your throughput and your production cycle, as well as cost savings by utilizing trend analysis. Let's jump into the demonstration. Today, I'm using the Atos Q with a rotary stage to show you how quickly we can capture accurate data on this injection molded part to achieve digitalization. Alright, now let's get started. I'm opening the digitized workspace inside the GOM Inspect software, where you'll see the live view from one of the camera angles, as well as the 3D view inside the software. The first thing I'm going to do is show you how quickly we can acquire our scan data and take a shot. I'll change the view so you can see the fringe pattern projected onto the part. Just like that, we acquired our scan data, and you'll see it come inside the GOM Inspect software. In one shot, you acquire really good data of your part. I'll now utilize the rotation table to acquire even more views of the part and capture the full field view of our injection molded part. So, the Atos Q utilizes three separate optics. It has a left camera, right camera, and a projector down the middle, capable of capturing 12 million points per scan. While this sounds like a lot of data, it quickly translates into a highly detailed digital twin that supports many downstream applications. Our software processes and polygonize the data quickly, streamlining production, development, quality control, manufacturing, and production processes. So you can see after just a few scans, we're able to acquire full data of one side of our part. What I'll do now is simply flip the part over and repeat the process again on the opposite side. So the Atos Q utilizes the triple scan principle to capture data using the view from the left camera, right camera, and both cameras together. The main advantage of the triple scan principle is speed. If your part exceeds the measuring volume size, the software can still stitch each scan together to obtain an accurate digital twin of your part. Earlier I mentioned measuring volumes. This measuring volume we're utilizing here today is the 350 millimeter measuring volume. So that's the blue field of view or wireframe that you see in the software. Now that we've acquired data from both sides of our part, we'll make both sides visible, and you can see that they're kind of laying inside one another. We'll go to the top of the screen and click Combine by Common Reference Points. From here, the intelligence of the software notices the reference points that are in common from side A to side B and stitches both scans together. Now you can see that we have a full, complete scan of our part from side A to side B. So now we'll go to the step of polygonizing our scan data. What's happening here is the software is creating a digital twin from the millions of data points that we captured during the scanning process. It intuitively minimizes the points with overlapping data so it's in perfect shape to support downstream processes. Now that we have the polygonized mesh representing our digital twin of the physical part, let's take a look at the quality of this data. Here we can see this part is made up of 926,000 data points, and I'll show this here while hiding the surface. So you can see in comparison to a CMM all these data points that are coming in. We're capturing these data points with the 12 different angles and shots that we took of our part, and from there we end up seeing all of these points being connected with polygons or triangles. And once those polygons are all connected, we then are obtaining our surface. So here you can notice how the software intuitively provides larger point spacing in planar surfaces while keeping tighter point spacing on radii or areas where the part needs to have more definition. Moving on, I'd like to show you how you can utilize the data with quality assurance processes. Once you have an accurate digital twin, there's a lot you can do with it to improve your quality assurance process, from first article inspection to tooling inspection. Let's suppose your part didn't come out correctly. Using the digital twin, you can go back to your tooling and inspect it. One example I wanted to showcase before jumping into the demonstration is Manheim, a global manufacturer of plastic components such as intakes and airboxes for automotive OEM companies. Initially, they were using CMMs, and once they transitioned to digitalization through FullField Data capture, they significantly reduced their tuning loops and improved their overall efficiency by 84%. With a detailed, accurate digital twin, they could quickly determine the corrective action rather than their engineers spending time in a room trying to figure out what the data was telling them. We often hear from our customers that Atos allows them to truly be an engineer. Instead of trying to interpret the data, they already know what the problem is, so they can spend more time thinking critically about the resolution. Let's jump back into the software where I will show you how we can inspect both our part as well as the tooling that made this part. To begin our inspection process, we'll jump over to the inspection workspace and we'll bring in our CAD model for comparison. The first thing we need to do is align our two models, so we'll create a pre-alignment. Once we've made our pre-alignment, we'll create our color map or our surface comparison on CAD. Here we'll get a color representation of what's happening with relation to our CAD model. Anything that's blue will be below our CAD model, green will be most similar to our CAD model, and red will be above our CAD model. To get more information from this color, we'll add deviation labels. So that's how quickly we can get a color map of what's happening to our part. Now I'll demonstrate how quickly we can create some diameter checks as well as flatness checks. First, we'll show our CAD exclusively, and then go and select our element of interest and create it. After a few short clicks, we're able to check our diameter. If we want to check flatness, it's as simple as going to our quick GD&T Create tool, select flatness, control-click, and out will come our results. To better understand how we got this number of 0.009, I like to visualize the color map to be able to display how we're achieving that number. So that's how quick and easy it is in the software to be able to create elements. What happens if you have PMI built into your CAD model? Not only does the software instantly show results, but it also delivers an intuitive color map that can be used as a reliable tool to communicate results to anyone who works with or within your organization. Wouldn't it be nice if there was an even faster way to get your inspection results? Well, there is. Like Emily mentioned earlier, utilizing model-based definition, or MBD, provides a single source of truth for anyone who works with the part throughout its life cycle. With this process, we're using an annotated 3D CAD model containing product manufacturing information, or PMI, to communicate product specifications in one place, removing the need to relay a 2D drawing for dimensions, tolerances, datums, and GD&T. All of this can be imported into our GoInspect professional software to increase the speed and repeatability of your inspection process. Let's take a look in the software how we can utilize PMI data on this 3D printed part. Here you can see the mesh that we acquired of our 3D printed part. This time, instead of creating our inspection elements manually, I'll simply drag and drop in our CAD model with built-in PMI. As the part comes in, you'll see different GD&T checks, datums, and tolerances come in with our CAD model. All we need to do is simply click Recalculate, and the software will set the pre-alignment, and then out will come all of our different inspection results. Here you can see how quickly and easily you can utilize PMI data with your CAD model along with the GoInspect Pro software. Here I have a project of the tooling that made up the injection molded part that we just scanned earlier. With the help of the GOM software, we are capable of digitally assembling your parts to analyze different things such as die spotting, interference, clearance, finish, and fit. We achieve this by scanning the components separately and then driving them to their nominal positions where we can perform our various inspections. Once we have the two components aligned, we're able to visualize something like clearance. Here we can see in color how much clearance we have between the two tooling halves. This can be beneficial for you in the case that your part, when it's made, has too much or too little material, and you can find the root cause of why that's happening by looking at your tooling digitally. You can also visualize this in a 2D perspective in case that's something of interest for you. There are many ways digitalization can enhance production processes as well, and I'll explain a few. Like we discussed earlier, Atos 3D scanners are versatile, offering opportunities for you to grow your solutions as your digital transformation strategy also grows. You can start with a stationary setup like you saw today for product development and quality assurance, and eventually add automated accessories and cell boxes for production to accelerate the data collection process, increase repeatability, throughput, and reduce the possibility of user error. During the production phase, it's important to detect potential quality and production issues in advance. Digitizing the parts and comparing them is the key to detecting patterns and problems early on. The GOM software that I showed today has the ability to see how parts vary from run to run, back to a nominal, or part to part quickly and efficiently. We call this a trend SPC analysis. It not only shows the part's trend, but can also build our golden part from actual data and shows when and how many parts it will take for a tool or die to wear out. Let's take a look at a trend project in the GOM Inspect software and also briefly touch on reporting. Here I have a project with 5 different scans of the injection molded part. First, let's take a look at our surface comparison. Here, we have our surface comparison in relationship to the CAD model, and we can see how it changes over the 5 different scans. We can also reference a single mesh and compare each mesh to that single mesh and see how our part's changing as we are producing parts. This can be useful in the manufacturing process to identify when your tool is possibly wearing. We can also change our legend so that it's showing a range legend where we can see the highest range of values on our part and where that might be. We can also get a more statistical value or more statistical idea of what's happening to our part utilizing a CPK legend. Finally, if you want to get more information out of your deviation labels, you can simply select them and change the checks for them into trend checks. And this will give you information over the 5 stages of what's happening to your part and give you information such as average, sigma, min, max, PP, and PPK values. All this information can be easily reported and shared with your team members with a quick capture in the software. Click OK, and if you jump into the report workspace, you'll be able to visualize that and share it with your team members from here. Here is a list of some of the things you can do to advance your digital transformation journey using the same sensor to enable digitalization throughout each process. That's the power of using FullField Data to support your digital transformation journey. But it doesn't stop there. Like Emily mentioned in the beginning, digital transformation is a continuous improvement journey powered by accurate data and the intelligence it enables. Emily, can you give us some insight on the future outlook for digital transformation and where the journey is headed next?
Yes, I can. Thanks, Griffin. We're also seeing some interesting trends that point to how transformative technologies are continuing to develop. We're seeing 3D scanning support the advancement of adaptive machining by increasing its speed, accuracy, and efficiency. We're also seeing an increase in AR and VR integration to support the design process through simulation. AR and VR integration also promises many strong organizational benefits. For example, a report by Capgemini Research Institute found that more than 82% of manufacturing companies who have implemented AR and VR say the benefits exceeded their expectations, including increased efficiency, productivity, and safety. AI and ML is further enhancing the benefits of digital transformation. One example is by replacing repetitive tasks to achieve faster throughput. But for the industry to begin to truly reap the benefits of AI, it needs to adopt FullField data collection as a standard. With complete, high-quality data sets, there is potential for AI to make intelligent decisions through machine learning and eventually take over the basic decision-making processes for us in the future, which will help to increase production speeds and further enable lights-out manufacturing. But first, we need to secure consistent access to accurate data. The more accurate your data is, whether you're a machine or human, the better, faster, and more reliable your decision making is because, as I said in the beginning, accurate data is always at the core of every successful decision. Today we took you through a digital transformation journey, from concept to strategy to process and implementation, explaining why 3D metrology is a critical success factor for this initiative. We covered the concept, deciphering what's real versus hype, and then discussed leveraging this strategy for various competitive advantages. Then Griffin showed us how easy it is to step into digitalization with Atos 3D scanning and explained some of the benefits of what you can do with that accurate data to improve your organization.